We are making this video for ME223 by following the Pichachka method. We answered the why, who, and what questions as follows. Why to do it? A better mug will allow the drinker to enjoy their beverage more fully and at the preferred temperature. It is convenient to be able to see what temperature the beverage is at. Who is our consumer? Any fine beverage consumer, coffee and beer drinkers alike, cold and hot beverages. What is it? It's a mug that will be able to hold liquid at a desirable temperature. Temperature sensors will read back accurate temperature on an LCD screen. The real-world rationale to design an insanely good thermal mug, which means that when the consumer pours a beer or soda into the mug drops the temperature of the beverage down to about 0 degrees Celsius and keeps it there for a long time. Goals for this project: to build an Arduino-based temperature measurement system with an LCD temperature readout and a waterproof temperature sensor. To build a MATLAB model that predicts the equilibrium temperature of a mug filled with warm beverage. You can model phase change materials and thermal mass, for example, thick glass wall. Explain how to apply the scientific method and then given an example in the context of this project. Created our recommended design for a thermal mug. We modeled the thermal mug on software by using SolidWorks and 3ds Max in order to get what concepts we need. The following pictures show my model that I did for the thermal mug. This view shows the location of the LCD that displays the temperature. The shape, color, and components of the mug are shown. 5 concepts that will be discussed are 1. The definition, 2. Benefits of using the experimental design process, the process itself, the belief system, and benefits believing in science. The definition, experimental design, is a design of any information gathering exercise where variation is present. It includes systematically planning, executing, analyzing, and reporting an experiment. The aim is letting the data reveal what is most likely true. Benefits of using the experimental design process. It's enjoyable to do since we design, build, test, and loop back. This is the best possible way to learn engineering. The data from the real world gives you feedback on whether or not you understand. When you understand, your math model and data are aligned. It is more reliable data. Essential for credibility, technical work must be presented using the scientific method. It gives investigators or researchers adequate control to analyze and establish cause-effect relationships. It provides helpful insight. As for the process, the first step, why? Figure out the reasons for doing the experiment. Second step, knowledge construction. Third, making predictions. We have to state the hypothesis. This step is not always done. Fourth step, document your work, goals, steps, and analyze. Step 5, review throughout and compare. Step 6, after finishing, go back and review the process again. The belief system. The scientific method is a belief system about the world. People tend to believe in science or to believe in alchemy. Scientific belief system by using evidence and data, and alchemy belief system by trusting emotions and beliefs. Here is the Arduino code. In our design, we had the following key features. Reflective thinking is most important because it allows us to look back on our past experiences as a group and be able to know and understand, on some level, how each other are thinking and what each person expects. Moreover, modern society is becoming more complex. Information is becoming available and changing more rapidly, promoting users to constantly rethink. As a consequence, we are required to apply RT as always to boost our minds' ability to conquer the obstacles that we face as engineers. We applied reflective thinking principles in a couple different ways. I personally use reflective thinking in a rebuilding the prototype to its current design. From past engineering classes, I learned that simpler is in most cases better, and that's what I tried to do. We use reflective thinking in Arduino programming. It's important to provide and keep documentation because with documentation, it's easier to do reflective thinking and critical thinking problem-solving skills. It's hard to look back and then try to learn what you could have done better if you don't have any documentation of your original ideas. In our team, we had strong qualities as follows: defining roles, organizing, and collaborating, the ability to apply that between each other in order to make sure that all tasks are covered and assigned to the best in their field, collaboration, all tasks were tackled. Team skill, we worked in a rhythm, everyone respected each other, and we used the diamond method for all of which ideas were the best. Time management, the team members were all assigned to do tasks in a specific amount of time, and the team members were aware of the responsibility. Thus, we finished the project by time and double-checked our results. Some improvements of my team. Meeting sessions. In the future, we would like to do more work on the meeting sessions between us, since we do need to meet a lot to check the prototype, but due to classes and unsymmetrical for each one, we had troubles on meeting altogether. Encouragement. Take away performance pressure by adding perspective. This is a skill we would like to improve on in the future, since it is very important for each one of us to feel positive and eager to finish efficiently. Unembracing mistakes. It's important among a group to acknowledge bad results, in order that us a group to find solutions, thus we get rid of them, and we did learn. Don't embrace errors that you find out inside yourself from the group. Thank you for listening.